When working on machine learning projects, data scientists spend a significant amount of time exploring and understanding their datasets. This involves creating various visualizations, analyzing distributions, checking for biases, and understanding relationships between features. Traditionally, this requires writing custom plotting code for each type of analysis, which can be time-consuming and error-prone. In skore version 0.10, we introduce the data accessor to the EstimatorReport, a powerful tool that simplifies dataset exploration and visualization, making it easier to gain insights from your data. Now, the EstimatorReport not only reports on your model performance, but also on the dataset. Let's see how the dataset accessor can accelerate your data analysis workflow. We begin by loading a dataset whose task is to predict employee salaries. We also split our data. The data is from a county in the US from 2016. Next, we get a strong baseline pipeline using a tabular pipeline from the Scrub library. Now, let us get its skore estimator report. We use the helper. We notice the new data accessor that is available since skore version 0.10. Now, let's take a look at the data accessor and see how to make simple yet efficient plots of your dataset to gain insights. So we use .data.analyze, and data source equal trains means analyzing only the train set. So the direct representation of the display is a table report from the Scrub library of the input dataset. In the Table tab, we can see the dataset along with the target column, which is current annual salary. In the Stats tab, we can see the summary of statistics of the dataset. We can see the column names, the null values, the unique values, the mean, the median, etc., etc. So there is no need to write pandas code such as df.dtypes, df.describe, etc. In the distributions tab, we get plots of the distribution of the numerical columns, such as here, and the value counts of categorical columns. It can also spot some outliers. In the associations tab, we get the correlation matrix of the columns with two statistics, Kramers-Weil correlation and Pearson's correlation. Pearson's correlation can only compare numerical columns, while Kramers-Weil correlation can compare all kinds of columns. For example, here, the Pearson correlation is not defined. Only here, for example. So the interpretation of Kramers-Weil correlation is similar to Pearson's correlation. And here it warns that two features seem to have the same information. So department and department name. So indeed, going back to the distributions tab, by comparing department and department name, we can see that Pol is the equivalent of Department of Police. As usual, we can easily glance at the available options of the display using .help. To begin with, let's plot the gender distribution to check whether we have some population bias. The dataset is somewhat balanced with a clear majority of males. Next, we colorize this distribution using the salary to predict. We observe that the median, the black vertical bar, is slightly higher for males. We can also observe that there is an outlier at $300,000. Now, let's add a third dimension to this plot by visualizing the hired year. The year is on the x-axis and the salary is still represented by the color. As this plot is getting a bit hard to read due to the large number of data points, we can slightly subsample it to see that a pattern emerges. As expected, newcomers at the right of this plot are paid significantly less than more senior employees at the left of this plot. Now let's switch gears and observe the correlation among our columns. Let's also tweak the keyword arguments of the heat map to change the color map. We observe that the feature the most correlated with our target is assignment category, which can be either full-time or part-time, as well as the employee position title. The comprehensive data analysis we conducted is crucial for feature engineering and model selection decisions, which are the next steps of the modeling pipeline and are not covered in this short demo. For example, we discovered that two features, department and department name, contain identical information and that the target contains some outliers. That's a wrap for this short demo. With Skore's data accessor, we hope that exploring and visualizing your datasets will be much easier and more efficient.